So what we're going to look at is quadratic graphs still, but we're going to look at them in a different form. When we first started doing quadratics, we looked at solving for the roots, which let us then solve for the turning point. But then we learned about the quadratic formula, and then we learned about the nature of the roots, and then we learned that not all quadratics have roots. So what we're going to do is look at a way in which we can find the turning point of a graph of a quadratic when it doesn't have any roots, like you can hopefully see with these 4 examples. Okay, so we're going to look at them in general, and then I'm going to do some examples on the other page. Okay, so if you remember the important parts of a quadratic, it was the roots, the y-intercept, the axis of symmetry, and the turning point. So I've only given you the turning points here, and I'm hopefully going to show you how to find the equation of the graph. Okay, if you see here, the x coordinate is 3. Right, so I changed the sign of the x coordinate and put it inside a brackets with an x and squared it. And then we've got the y coordinate is 2. And that is the equation of the quadratic in what we call completed square form, okay, which we're going to come to in another video. But what I want you to understand in this video is how to read off a graph, or in reverse, how to sketch a graph from here. So, last thing we need to get is the y-intercept. And if you remember from when we were sketching them way back in that video, to find a y-intercept, you let x equal 0 because it's on the y-axis. Zero minus 3 is -3. Square that means you do -3 times -3, which is 9, plus 2 is 11. And so the y-intercept is 0, 11. And then the last thing would be the axis of symmetry, which is if the x coordinate of the turning point is 3, x equals 3. Right? So let's do another one. When I had the turning point in this question, I changed the sign of the x coordinate. So if we change that from -2, we're going to end up with +2, all squared, and then it's going to be +5. Okay. If that had been below the x-axis and it had been -5, then it would be -5. So the y coordinate stays the same, the x coordinate changes. And then just find the y-intercept. Zero plus 2 is 2, 2 squared is 4, plus 5 is 9. And so the y-intercept is 0, 9. Okay. So the main difference between these two and these two is that these have maximum turning points instead of minimum turning points. And if you remember from quadratics, that means the coefficient of the x squared is going to be negative. Okay, but I'll show you how to deal with that. X coordinate, we still treat that the same. Change the sign of it. X minus 5 all squared. Y coordinate -3. Now I've not dealt with the fact that it's negative, so all we need to do is minus there. And the negative goes outside the bracket. Okay. A more common way of seeing that, however, is -3 minus x minus 5 squared. So you could see it either way, but that means the same as that. And then the last thing we need is the y-intercept. Zero minus 5 is -5. -5 squared is +25, so it's -3 minus +25, which is -28. And so that coordinate point is 0, negative 28. And that just means I've realized I've forgotten my axis of symmetry here. X equals negative 2. And then x equals 5. Last one, negative 1, negative 4. So we're going to get negative, because it's a maximum turning point, x, change the sign of the x coordinate, minus 4. Right. Last thing we need is a y-intercept. Negative 4. 0 plus 1 is 1. Squared is 1. So it's minus 1. That's negative 5. So that is 0, negative 5. Okay, so that is the quadratic graph, but in completed square form. So that's me just explaining it. So what I'm going to do is now have some questions. Okay, so if we turn it over. That's in the camera. Yep. So, 2 questions where I'm going to have to sketch the graph, and then 2 questions where I'm going to have to do what we just did before. Okay, so first thing we need to work out is what is going to be the turning point. So we look here, remember we changed the sign of it. So turning point, or t dot pt, will equal, change the sign of the x, keep the y the same. Okay, and we can see that this is going to be a positive graph. So we draw the axes. Three, 4, like that. Except maybe a bit nearer than yours. Then we've got the axis of symmetry. Last thing we need is a y-intercept. Zero minus 3 is negative 3. Squared is 9 plus 4 is 13. So that is the point 0, 13. Okay, let's do another one. Except this time it's going to be a negative graph. Let's firstly work out what the turning point is going to be. Change the sign. And keep the y symbol, the sign, the same. So it's negative 4, 2. Except this time it's going to be a negative graph. So instead of going like that, it's going to go like that. So negative 4, 2, roughly. And the last thing we need for this one is to get the y-intercept. Zero plus 4 is 4, squared is 16. 2 minus 16 is negative 14. So that is 0, negative 14. And the y-intercept, sorry, the axis of symmetry will be x equals negative 4. Okay. So all we need to do is, just like we did before, write down the equation, y-intercept, and axis of symmetry of the following. Okay, so let's firstly get the equation. Change the sign. Plus 3. So for the y-intercept, zero minus 5 is negative 5, squared is 25, plus 3 is 28. And so this is going to be 0, 28, and x equals 5. Right, last one. Change the sign of the x. Keep the y the same. Let's get the turning point. Bring the axis, the y-intercept. That should be minus. So 0 plus 2 is 2. Squared is 4. But then there's a negative outside the brackets. So it actually ends up being negative 4. Minus 1. Negative 5. So we end up with that being 0, negative 5. And then the axis of symmetry being the graph of the equation x equals negative 2. Okay? So that was quadratic graphs in completed square form. Okay?